Today we will be focusing on water's viscosity and surface tension, so before we begin with them, let's get a better understanding of water. Water is a covalent molecule. It has 6 electrons in its outer shell and bonds with 2 hydrogen atoms to fill it. In reality, it looks like a tetrahedron. This is why water molecules appear bent, because the bonded pairs of electrons are not shown. Water is also polar. This means that it has a slightly negative and a slightly positive end. This charge is shown with a funky looking S. These negative and positive ends create attractions between other like molecules, called intermolecular forces. In water, these are called dipole-dipole forces, and more specifically, hydrogen bonds, the strongest intermolecular force. Hydrogen bonds only form with nitrogen, oxygen, and fluorine, as they are the most electronegative. Because oxygen is electronegative, the hydrogen is highly attracted and its electrons are pulled closer to the oxygen, creating a polar covalent bond. Now to viscosity. It is measured as the resistance of a liquid to flowing through a thin tube, or how thick a substance is and how easily it flows. For this experiment on viscosity, we are using 4 different liquids. From left to right, we have olive oil, water, hand wash, and vinegar. Using a ruler, place 4 cooking beads on the top of each glass and pull the ruler away at the same time to ensure the experiment is valid. The controlled variables, to ensure further validity, are that a dry bead is used each time, the glasses are the same size and contain the same amount of liquid, and repeat the experiment 3 times to ensure reliability. The results show that the most viscous liquid was the hand wash, followed by oil, water, and vinegar. In this experiment, water was less viscous, but relative to similar sized molecules, water has a much higher viscosity. This is due to its hydrogen bonds. The hydrogen bonds are very strong and cling together, making movement more difficult than other similar sized molecule solutions. In everyday life, viscosity has impacted on the evolution of marine life. Many creatures are streamlined so that they can move quicker through the ocean water. For example, a shark has a much smaller relative surface area cutting through the water compared to the cooking bead. Surface tension. The bonding that occurs between water molecules creates a skin on the surface of the liquid. Compared to most other liquids, water has a very strong surface tension. To look at the surface tension of water, we are going to see how many drops fit onto a $1 coin. Do it 3 times to make it reliable, and use the same coin each time to make it valid. We are not changing liquids, as the other liquids used previously do not always form droplets, so there is no independent variable. The skin on the water is the result, once again, of the hydrogen bonding in water. Water molecules are bonded to others all around them, so at the surface, when there are no other molecules above, the hydrogen bonds turn around and create extra strong attractions with the molecules beside and below them. This also reduces the surface area as the molecules are brought closer together. This is why raindrops are the shape they are. They have a skin because of the hydrogen bonding. This ideally makes a spherical shape. They have a teardrop shape due to gravity. That's all for today's video. Thanks for watching.